Variation and proportionality. Let's take a look at this equation first of all. Y is equal to 2x. And I have a question. The question is, as x gets larger, right, y gets what?
More?
Think about it. Maybe plug some numbers in there. Huh?
Larger. I don't think it's larger.
Right. And so you could see here, one thing you could do, and you could do this in your mind, and I hope that you guys are writing this down, right? You have to write down everything that I write down. I am not just decorating the board here, right? So if it is that, what we could do is we could actually plug in values just to see, right? So we could plug in values of x is 1, and you notice we're plugging in the values of x, not y, x, because it'll be easier to work out, you know? So when x is 1, what will y be? That's all, that's all, oh gosh, come now, 1 multiplied by 2, really. Fellas, ladies, gentlemen, when x is 2, y is what? 4. Because x is 2, so 2 times 2, remember this 2x means 2 multiplied by x, that's what that means. So when x is 3, y is what? Yeah, oh gosh, really? Is add maths we talking about here or what? When x is 4, where's y? Dot. So we could see here that as x gets larger, y is also getting larger. So as x gets larger, y gets larger. Right? Let me ask you something. For this same equation, y is equal to 2x. The same equation, right? As x gets smaller, y gets what? Smaller. So we could see here that they both kind of have, you know, they both kind of have this same kind of thing where as if x gets larger, so x starts to climb up, then that means that y will also get larger, right? Y will also start to climb upwards. But if x gets smaller, y will also get smaller. Oops. Okay. So easy so far, right? So we say in a situation like this that y is proportional to x. And what we say is y is, and the term is directly proportional. So y is directly proportional to x. So that means that if x goes up, y will go up as well. If x goes down, y will go down as well. So does everybody understand what directly proportional means?
Yeah.
Alright, I hope so. Because you know when the questions hit you, it'll be a different story, right? So we come in again. If I have this, y is equal to 1 over x. Right? So now, as x gets larger, y gets what?
Smaller.
Thank you very much. Y will get smaller. And if you want to know how, just do a table. You choose in any values of x that you want, right? So let me see. When x is 1, what y is going to be? When x is 1, you literally just, we do a class on substitutions, by the way, remember? You just take this one and you just put it where x is, and that's all you had to do. That's all you had to do. So when x is 1, y is going to be 1 over 1. 1 divided by 1 is 1, right? So when x is 2, what is y going to be? This elementary stuff I'm asking here, not hard stuff. So tell me the first thing that comes to your mind. Aha, right? Isn't it 1 over x? So when x is 2, it'll be 1 over 2. Y will be 1 over 2. So now you have the 0.5 there, Ariel. Right? So when x is 3, what is y going to be? Thank you. And when x is 4, what is y going to be? Thank you. And when x is 5, what is y going to be?
1.
Thank you very much. So you could see here that as x is getting larger, so x going 1, 2, 3, 4, 5, the value of y is actually getting smaller. Y start off at 1, and then it went to a half, and a third, and a quarter, and a fifth. Right? So as x gets larger, y gets smaller. So what we say here, right? And you know what? Let me do the other one. We ain't done yet, right? So we can see here that as x gets larger, y gets smaller. But let me try this one. What will happen if as x gets smaller, y gets what? Larger. And you can see it plainly with this very same diagram here. You can see it with the same diagram here. That if you start at 5 and you go smaller, 5, 4, 3, 2, 1. As x gets smaller, y will go from 1/5 to a quarter to a third to a half to 1. So y will be getting larger. So we could see here that we have a situation where as x goes in one direction, y will go in the opposite direction. So if one getting big, the other one will get small. If x gets small, y will get big, right? So this is why in a fraction, the bigger the denominator, the smaller the fraction. This is the reason why, right? And so we say here in this case that y is inversely proportional to x. Notice the difference in the terminology. Directly proportional means that they're both in the same direction all the time. Inversely proportional means that they both go in opposite directions all the time. And we write it like this. Y is, this is the proportional sign, and we put inversely proportional to x. So does everybody understand the concept of directly proportional and inversely proportional? You guys understand the difference? If I have y is equal to negative 5x, is this directly proportional or inversely proportional?
Inversely.
I have one person say inversely. Do I have any other answers? Alright. Can you guys justify your answers? How do you justify directly? The easiest thing to do is to draw a little table, X, Y, and start plugging in values for X. So X is 1, X is 2, X is 3, X is 4, X is 5, so on. When X is 1, what is Y? Negative 5. That's 1 multiplied by negative 5. When X is 2, what is Y? Negative 10. When X is 3, what is Y?
Negative.
When X is 4, negative 20. When X is 5, negative 25. So we could see here that as X gets larger, what is happening to Y, Scotia? Right, so we could see here that Y is getting smaller. So therefore, we could say that Y is inversely proportional to X. Now, I hope I spelled inversely proportional correctly, right? So you can see here, and you could also write it as Y is inversely proportional to X like this. Even though it doesn't have a fraction in it, it's still inversely proportional. Right? So everybody understands this? Alright, now. Now if I was to tell you that every time Ariel makes some money, right? So every time Ariel makes some money, right? That means that Scotia making money as well. So once Ariel get more money, then Scotia gonna get more money, right? So that means that if Ariel money going up, then Scotia's money is going up, and so what kind of relationship is that?
Directly proportional.
Right, so it's directly proportional. So we could say that Ariel's money is directly proportional to Scotia's money. But that doesn't necessarily mean that Ariel and Scotia have the same amount of money. It could be that Ariel, every time Ariel make $2, Scotia making $10. Right? It could be that every $1 Ariel make, Scotia making 50 cents. Right? It's still more, right? So if we say that Ariel's money is directly proportional to Scotia's money, so as Ariel get more money, Scotia also getting more money, right? Is it correct then to form this equation? No, it's not. Why? Because what? Scotia, you was on the right track there, I think. I think it was you.
Yeah.
Because why? I just told you the answer. Why?
I heard it all values.
Because you're not sure if it's the same amount, if it's going up by the same amount, right?
Yeah.
Right. You're not sure if it's going up by the same amount. So you can't just say, because both of them are directly proportional, you can't just go and say, well, all right, y is equal to x. No, that's not particularly correct. Because you know that Scotia, Ariel could be getting 3 times the money as Scotia. And or Ariel, because directly proportional. So Ariel could be making 6 times the money as Scotia. And or Ariel could be making 1/2 times more money than Scotia. So at the end of the day, if 2 things are directly proportional, you cannot just go and say that they equal. No. Because we don't know what is the proportion. So what we do is we put this value K. And what we say is K is the constant of proportionality. That is what K is. K is the constant of proportionality. So therefore, the point that I'm making is, if you have a statement that Y is directly proportional to X, you cannot immediately form an equation unless you have a constant of proportionality. It is the constant K that will make the 2 of them equal. Yeah? So, do you guys understand why we need a constant of proportionality if we are forming an equation?
Yeah.
Caitlin, you alright?
Yeah.
Alright. So, similarly, if I say that for every fish that Scotia buy, no, not Scotia, Shazay, for every fish that Shazay get, not for every fish, but as Shazay get more fish, Caitlin fish dying, right? So Caitlin losing fish. So as Shazay getting more fish, Caitlin losing fish. So obviously this is an inversely proportional relationship, but we don't know exactly how much. So we don't know. Next thing you know, every one fish that Shazay get, Caitlin could be losing 2 fish. We don't know, right? So in order to form an equation, we are going to have to put the proportionality. We can see here that this is inversely proportional, and we're going to put the constant of proportionality in front of it. Yeah? So because we put the constant of proportionality in front there, remember when it comes to adding multiplying fractions, this is actually K over 1 being multiplied by 1 over X. Right? So you see where all of that number theory stuff is coming. So therefore we could say that Y is equal to K over X. So does everybody understand the constant of proportionality and how we form an equation? So check this one out. Take 2 minutes and see if you could solve this. Alright, I'll give you 5 minutes.
And the answer will be equal 1.
Alright, now you are using, and what you're doing is not particularly wrong. You are using a good bit of reasoning, right? And you're using some good logic there, but you're not using the algebra, right? So at the end of the day, like we want to form an equation. Now at the end of the day, yes, you can use simple logic to work out a question like this, and this question is variably simple. But sometimes in a situation in life, the question isn't this simple, right? The problem that you have in front of you, because all of these variations and proportions questions are going to be like this, where is kind of life applications now. right? So at the end of the day, you're gonna have to be able to form an equation. So what is the equation here? Any ideas? Anybody? Alright, so let's read the question. The number of hours. First of all, remember how I just read a question. You don't read the whole question, you read piece. So the number of hours, let's call that H, required to do a job varies inversely. Alright, so I know what that means. H will vary inversely to as the number of people working. So let's call that P. Right? So you can see here that literally the question gives me everything that I need to know. So we could see here that the number of hours vary inversely to the number of people working. Right? So, and I could also do it the other way. I could also say that P varies inversely 1 over H. Both of them are actually the same thing. Yeah. So you could have done it that way as well. So now that I have this relationship, I could now say, well, okay, we could form an equation. H is equal to K multiplied by 1 over P, right? Where K is the constant, and you always have to put this of proportionality, constant of proportionality, right? So we could also say that H is equal to K over P. Right? Everybody understand how I got this equation? Right. So now they gave us information. They say it takes 8 hours for 4 people to paint the side of the house. So I have this equation here. H is equal to K over P. I don't know what K is. K is a constant. So K is not a variable. K is not going to change. Like how X does change and how Y does change. K is never going to change. K is a constant. So we have to find out what the constant is. So now they tell us, they give us all the information. They say it takes 8 hours. So 8 hours is equal to K over 4 people. So now it's easy for me to find K. Therefore, K is equal to 8 multiplied by 4, which is what? 4 8 so what? 32? So now we have the equation. Therefore, H is equal to 32 over P. And this is our final equation here. And with this equation, we could find out any amount of hours, any amount of people we want. So now they ask us, well, how long would it take for 5 people to do the job? Well, for 5 people to do the job, right? How long would it take? How many hours? So H would be 32 divided by 5 people. So H would be, where's 32 divided by 5? 32 divided by 5, which would be 6.4 hours. Right? So if it takes 8 hours for 4 people to do it, for 5 people to do it, it'll take less time. So you see there that as the number of people went up, right, the number of hours went down. So it's inversely proportional. So Ariel, with your reasoning and logic, did you get 6.4?
No.
You didn't. Yeah, you didn't. Right.
Because I calculated for one person, how much it will take for one person,
Mhm.
and multiply it by 5.
Right. So you basically went like this. 8 hours is 4 people, and
Yeah.
so therefore 1 hour is 4 divided by 8 people. Yeah, that's the kind of thing you did, right? Now this is not particularly wrong, but at the end of the day, this will only work if like you can see here that you're not using any constant of proportionality. The thing is that these two quantities, the hours and the people, are proportional. That does not mean that they're equal, right? So that does not mean that as you go up 1 hour, you had to put up 1 person. If you go up a next one, it does not mean that they are linear, that they will go up 1 step by 1 step, both of them. You understand? And not only that, but if you was to notice, because let me ask you something. Did you get a bigger number? What's the number you got? Right. So you got a bigger number, right? Which means that your version is directly proportional, isn't it? Right? So you have to be careful about that. But you understand what we did here?
Yeah, I understand, but like I think I might need to do it on my own.
To really grasp it. Well, let's just look at this here. The number of hours. So I just looking at my variables. What are my variables? The number of hours is the first one, so that's 8. Required to do a job varies inversely, so they're telling us about the relationship here. So as soon as I see it varies inversely, I can then put on H is proportional to 1 over what? The number of people. So people. Right? So every little part of the question. And then you have to form your equation with your constant of proportionality. So once you put that equal sign, you have to put a constant of proportionality. And then the usual question will give you all of the information that you need to find your constant of proportionality. Right? So you can see that we use the information to find the constant of proportionality. 8 hours, 4 people. So we put 8 hours, 4 people. Constant of proportionality is 32. So therefore, for 5 people, we could find for how much hour. Shazay, Caitlin, all you understand this? So Caitlin, you could talk me through this one?
I could try.
All right, let me hear it.
So B and then it's
Sorry?
B for volts and then it's proportional sign and then A amperes. That's the percent.
All right, so you have V is proportional to A, okay.
Then I put 15 for the volts and 5 for the amperes.
Where you didn't have to form your equation first? This is not an equation. This is just a statement that V is directly proportional to A. And so the electrical current, now anybody who did physics will know that the symbol for current is actually I, right? But really and truly, these maths, it doesn't really matter what symbol you use. So you could use C, and she, in this case, she used A because it's amps, right? So she used A. So the electrical current, and we'll use that A, right, in a circuit varies directly as the voltage, right? So therefore, the electrical current A, it varies directly with the voltage. So as the amps go up, the volts go up. So you can't just go plugging in values because this is not an equation. All this saying is that they are directly proportional. So now you have to say, therefore, A is equal. Now that once you put that equal sign, you have to put a constant of proportionality, KV. You understand that? Caitlin? Did you take that step? No? Alright, yeah, you had it, but you didn't have the key. So that means you didn't take that step, right? K is the, and that's good, thank you for asking, because you have to say K is the, you have to state it, the constant of proportionality. Did you guys miss that in the last couple of questions? And let's just look that over again, because it seems like the point has been lost, right? At the end of the day, when you have, like, take this for example here, when we did it just now, right? Yeah. When you have this, right, y is inversely proportional to x, or y is directly proportional to x. That's not an equation. Remember, we was talking about the money or the fish. We don't know exactly how much. All we know is that it's inversely or directly proportional. We don't know exactly how much. So when forming an equation, we have to put k, a constant of proportionality. We don't know what the constant is, right? But hopefully we should be able to figure out, with information, we could figure out what the constant is. So once you form your statement that something is inversely proportional or directly proportional, once you go to the next line to form an equation, you have to put your constant of proportionality. That's what we did here, right? When we said that, okay, the hours of people varied inversely with the hours of people here. The number of hours vary inversely with the number of people. So once we formed an equation, you have to put your constant of proportionality. Okay? So your constant of proportionality is that unknown number that you don't know, and that number really defines what it is. That number really defines what the relationship really is. So in this case, you see here that we have the electrical current A in amps in a circuit varies directly as the voltage. So I have the amps directly proportional to the volts. So therefore, the next step is to form my equation. The amps are directly proportional to the volts, but you have to put equal to the constant of proportionality multiplied by the volts. You have to put your constant of proportionality once you are forming an equation. Now that we have the equation, let's see if they gave us any information to figure out what the constant of proportionality is. Remember, in a situation like this, the voltage could change, the current will change. As the voltage gets larger, the current will get larger. As the voltage gets smaller, your current will get smaller, right? But no matter how small or big, no matter how much your current and your voltage change, the constant of proportionality will always remain the same. So therefore, what they say here, when 15 volts are applied, so 15 volts are applied, the current is 5 amps. 5 amps. So now I have this equation. 5 is equal to K times 15. Therefore, K times 15 is equal to 5. Right? I just rewrote it. K is equal to 5 divided by 15. So therefore K is equal to what? A third. So K is equal to a third. So now that I have K, I could rewrite, therefore the equation is really supposed to be A is equal to a third the volts. Everybody understand up to here? Ariel, how you feel about it?
I understand.
Right? Shazay, you okay?
Yes.
Caitlin, are you okay? Right? So, oh, I like that was so cute. Yeah. That was nice.
I have one question.
Mhm.
So you see how you put 5 divided by 15?
Mhm.
Well, 5 over 15.
Mhm.
I would have written 5 and the division sign like 15.
Well, that's the same thing.
Oh, it's the same thing.
Well, that's what division means. 5, a fraction, right? If I had a fraction, like for example, 4 over 2, and this 2 just cancel, and you'll get 2 over there,
Yeah, but
right? So that this means 4 divided by 2, isn't it?
yeah,
And the answer is 2. You understand what I'm saying?
yeah.
Now, I know that you now started to look at the videos. We actually spoke about this quite extensively when we were talking about, and that was in one of the earlier videos, maybe the second or the third class, where we were talking about fractions, and we now started to talk about fractions, and we were talking about what a fraction means. And a fraction means a lot of different things, right? So if I have 5 over 15, that could mean 5 divided by 15. That could also be a ratio of 5 to 15. A fraction could mean so many different things. Yeah? So how you feel about that? And that is the thing, right? So it's these kind of simple things that we covered in these last 12 classes, which is why it's so important, Ariel and Shazay, that you guys catch up with these classes, because everything we do going forward gonna be based on those 12 classes. This is actually class number 15. Yeah. So Ariel, how you feeling? You okay?
Yes.
Alright. Now you understand how I got from here to here?
Yes.
All I did was flip it, right?
Mhm.
Right. And then you understand how I got from here to here?
Yes.
Right? You fling over the 15, eh?
Yes.
And in this case it was multiply by 15, so when you fling it over it'll become divide by 15, right? Right. But you actually put 5 divided by 15. Well, that is not wrong. That is correct. But because 5 over 15 is 5 divided by 15. Absolutely, they are the same. But just be careful if you write it like this, that you don't put your answer as 3, eh?
Well, guys,
What you do?
that's not saying that my answer would have been different. It would not have been 1/3 because other it would have.
No, 5 divided by 15 is a third. But you could see it a lot easier when you write it as a fraction, eh? Yeah, so what you did was you actually did 15 divided by 5, which is 15 over 5, like this, eh? Right. Right, so be real careful, and at the end of the day, it's super important that we understand these most basic kindergarten SEA stuff. It's super important because, you know, this is the stuff that has given us problems when we going into algebra. Yeah, it's never algebra, is never the problem. The problem is always arithmetic. Yeah. So you guys gotta catch up. You and Shazay have to catch up, right? So now that I have this, Now we could say, well, what is the current when 18 volts is applied? Well, A is equal to a third times 18, right? Which is the same as saying 18 divided by 3. Yeah. So A is equal to 6 amps. Anybody get 6 amps? Nobody gets 6 amps? Huh? Scotia? Right, well, what was the mistakes that you were making? What did you do?
I don't know if it was too long ago. Like I had these courses I had these.
You had V's proportional. No, that would not matter. You wanna do it like that and see how it would not have mattered?
Yeah.
Alright, let me do it over and see how it would not have mattered, right? Because remember, they're directly proportional. Even if they're inversely proportional, it would not matter which one you put first, right? So you saying that you had put the V first. V is directly proportional to A, right? That's what you said? So therefore, you would have gotten V is equal to KA, right? So now you had to plug in your values, right? So they say here, sorry, where's my eraser thing? That 15 volts. So I have 15 volts is equal, right, to K. I see what you mean though. Actually, 5 amps. Right? So yeah, boy, that is true, because then K will be equal to 5. Actually, no, it wouldn't make a difference. Watch why, right? K will be, well, you're flinging the 5 across, so 5 over 15. No, sorry, that's wrong. Let me write it the other way. 5K is equal to 15. Therefore, K is equal to 15 divided by 5. So now you get K is equal to 3, right? So let me show you how it would make a difference. So therefore, V now is equal to 3A, which makes sense. V is 3A and A is a third V, right? So that makes sense. So now they say when 18 volts are applied, well, 18 volts now is equal to 3A. 3A is equal to 18 volts. A is equal to 18 divided by 3. A is still equal to 6. Why are you making mistakes, Scotia? What?
It's pretty bad.
What? Tell us.
I didn't take into consideration
The multiplication part? What multiplication part? 3A? When I was flinging across the 15 over here, that K is equal to 3. Right. So in this case, and this is where Ariel probably did the same thing if she got K is equal to 3. At the end of the day, if it is that you flip and you do it in the opposite way, yes, you will get a different K. Right? In this case, K is 3. In this case, K is a third. But your final answer should be the same. It should not matter in the end. Yeah? Number 20. Same procedure. All of them is the same procedure. Right, who want to start it off now? Alright, nice. So let me see. Small on this, right inside there. I hope you all could see the question there. I know it might be kind of small. So what's the equation? Where's the first statement, Jimmy?
A is equal to 1.
No. A could never be equal to 1 over R. Never.
Not equal.
Right. Thank you very much. That is it, right? So A is inversely proportional to 1 over R. So how did she get that? The current in an electrical conductor, so I guess she called in the current A, varies inversely as the resistance of the conductor. So that's how she gets this. So then what? Right, so you have A. So now that you have your relationship, you can put A is equal to K over R, where K is equal to your constant of proportionality. Now what?
Put in the values.
Right, so if the current is 12 amps, so the current is 12 amps, then the resistance is 240 ohms. K over 240. So therefore, what is K? What you got for K?
2,800.
2,880. So that is what you got for K, yeah? And that is 12 times 240. The 240 is here, and if I fling it over, it's divided by 240. So it'll become multiplied by 240 when you fling it over, okay? So K is that. So now we could rewrite the equation. Therefore, A is equal to 2880 over R. What now? You're putting in new numbers, right? So therefore, what is the current? So they're asking for A when the resistance is 540. So therefore, the current when the resistance is 540. So nothing, no algebra here in terms of flinging across. So A is equal to 2880 divided by 540, which is what?
I don't know.
So that's now 2880 divided by 540 is 5.3. So you could see here 5.3. Now look at it, right? If we look at A and K, right? They say here that when A was 12, not K, sorry, R. When A was 12, R was 240. And then R went up to 540 and A went down to 5.3. So we could see here that as R increased, the amps, the current actually decreased. Hence, it is inversely proportional. Caitlin, you okay with this? Did you get 5.3? Ariel, how about you?
Yeah.
You got 5.3?
Yeah.
Boom, Shazay.
Yes, sir.
4 for 4. All right, you get 5.3, right? Beautiful. So obviously, the rest of these questions are just more of the same. And you can see there's quite a bit of them, but guess what? We have answers here too. There are 38 questions in all, right? You are expected to do them. And some of the questions are really easy, right? Write a formula to express the relationship described. A formula have an equal sign, right? So C varies directly as K. So what would the formula be there? Right, well C is directly proportional to A, but that's not the formula. The formula would be C is equal to KA. And?
Yeah.
Right? So what about this one? X is jointly proportional to Y and Z. Jointly proportional. Where's that one? So X.
Y and Z.
So Y multiplied by Z. Right? Now if you look at it here, if Z increases, right, then X will also increase. If Y increases, then X will also increase. If Z decreases, any one of them decrease, right? If Y decreases, X will also. So X is proportional to both Y and Z, directly proportional. Therefore, X could be equal to KYZ. Now, in the answer, I think that they actually have something different. So remember, you have many different ways that you can express it. Let me see what they have in the answer here. Number 2, right? So they actually make K the subject to the formula. That's all that they did. Yeah, they pretty much, we have X is equal to KYZ, and then they put K as the subject to the formula, and bring the YZ underneath here. So just be careful. You might have the right answer, but just, you know, have it in a different way, right? So you guys have to do this. All of these questions here, try it. They're not hard, they're real easy. So just try it and see how that works out for you. So before we go, we'll actually call it quits there. But before we go, there's one more thing that we have to do. One more thing, right? That is the variables. And this is super important. Importante. Right? You have the subject of the formula is equal to the rest of your equation. And we know here that this is directly proportional. We know that, right? At the end of the day, when we are checking this, when we were checking to see if they were directly proportional, what did we do? We write X, we write Y, we draw a little table. And then we start to input values of X. So we start to input the value of X. When X is 1, Y is 2. So this is the output. Yeah, and usually the output is the thing that you want to find. So Y, the output, is usually the subject of the formula. So X is this thing. Oops, that is a horrible arrow. I shouldn't try to do fancy arrows. X is the input, and when you input a value into X, you will get an output that is Y. Y is the output. Does everybody understand this input-output concept? Right? So, given that input-output concept, we could see here that we could put anything as X. We could just fling numbers in there, in the input. We could literally put anything inside of X. So X can be anything, but Y cannot be anything. Y is dependent on X. Yeah? Y is dependent on what X is. You have to know what X is before you could find Y. So Y is dependent and X is free to be anything. So we say here that X is an independent. Wait, I think I spelled independent wrong. Independent. Is dent or dant?
Dent.
Independent variable. X is independent. When you think about independent, you could think about freedom, being free like a bird, you know? So you could be free like a bird. I don't know if that's how you just draw a bird in all of them. Like Batman. And that's the symbol for Batman though. How they was doing it? They was doing it like this, and this and this. I don't know. I think that's the symbol for Batman, right? So when you think about independent, you could think free. X is free to be anything, but Y is not free to be anything. Y is your dependent variable. So Y depends on X. So how you guys feel about the difference between an independent variable and a dependent variable? Well, you know, are you comfortable with it? Right, that's all I want to know. Anybody have any questions? No? Today we did variation and proportionality. So we saw that this is a really, really useful tool, because if you notice, all of these questions here and the questions that we've been doing are basically real life questions. And you could apply this logic in real life as well. Yeah, in terms of recognizing if two things are directly proportional or inversely proportional. And once you recognize if these two things are directly or inversely proportional, then you can form an equation with a constant of proportionality. So once you recognize the relationship, you could form an equation. Once you form an equation, you could use data to find your constant of proportionality. And once you find that constant of proportionality, this here is actually your final equation. This is the completed equation. When you have found the constant of proportionality, then this is your completed equation. And then from the completed equation, you could basically find anything you need again from there. Right. So that will be it for today's class. So you see, I've given out a little half an hour early. You guys do have an assignment due for Saturday. However, it is not a hard assignment. It will look like plenty questions there, but them questions, they're easy, right? And at the end of the day, I understand that you guys are adults and you have lives and you have a lot of busyness and busy stuff. So when it comes to doing these assignments, I fully understand, and I'm okay if you can't do the full assignment. That is just true real questions. You see how many questions we do for laws of indices. We do real questions. Imagine I give all you 100 questions as the last your last assignment, right? So I might be throwing questions at you. Just do as much questions as you can do. That's all that I'm asking for, right? It's not enough. I'm not saying that you have to do every single question, but I want you to do enough questions so that when I look at your assignment, I could say, right, this person understands what they do. That is all I want. So it's not to say you don't have to do all the questions in the assignment. You just have to do enough so that I am convinced that you truly understand what you're doing. Right? So does anybody have any questions based on what we did today? That's fine. I'm here. I have to I didn't get a chance to review it yet, but I wanted to show you something. So thanks for reminding me, right? So when you go into your Google, you're seeing this, right? All right, classwork. So obviously these are all of the classes, right? And these are the assignments. So the assignments have this little symbol here. So this is an assignment, this is an assignment, and this is an assignment, right? Now, the class videos have what the class is about. Basic arithmetic, BODMAS, fractions, indices and standard form, right? And then here in the assignments, you'll see what the assignment has in it. BODMAS and fractions. And over here we have decimals, percentages, ratios, them kind of thing, right? Look, I see in here 2 people turned in this assignment, Scotia and wait, nobody else. So well, I guess, but Caitlin didn't do this. Oh yeah, look, Caitlin already did. Right. So the thing is that, is this where you go to get your assignments? Right. So when you go right here to get your assignment, do you upload it right here as well?
How I upload it when I was actually playing up with this.
Right. When you click on the assignment, right, you'll get the assignment there, but really and truly, like I am logged in as a teacher, so it wouldn't give me the option to upload the assignment, right? But when you have the assignment there, you should have an option to upload it somewhere around in the assignment itself. Yeah. So,
when under computations, right?
Computation.
I upload whole 100 questions in one.
So you do computations 1 and 2?
No, just
computations 1. So,
yeah.
So computations 1, this is the assignment here, and it really have real questions. It really does have, and look, it have a lot. So you do all these questions, child? Wow, well that's beautiful, eh?
I see it had like 2 pages with answers, so I didn't know. So when I do the fractions, I saw it had some stuff in red, and I realized that was the answer, so I corrected those 2 by myself.
Right, beautiful. And well, I mean, if you're looking for the corrections for the others, I don't know if we do all of them, but we definitely did most of them. And the corrections for the others will probably be in some of these videos here, right? So yeah, so these videos would have been the corrections for all of the assignments. Remember, once you do an assignment, or like for example, I gave you guys this piece of homework, right? Where is it? Intro to Algebra. If you look at Intro to Algebra, view more. Right? It's we do a lot of Intro to Algebra. Where is it? Oh, look, it's quite on top here. All right, variation and proportionality. I'll just pull it down because it's supposed to be at the bottom. Right, underneath that. Right. So this is the assignment, variation and proportionality here. Yeah, and when you guys do the assignment, next class we're going to be doing all of the questions. So the next class will be us doing the assignment. You understand? Right, so basically the corrections for these assignments are in these classes here. Yeah, so that is why you just look for the classes and see. Computation. So this is an assignment, and then you have this last assignment here, which was an exam actually, Okay. So, does that answer your questions, Ariel?
Yeah. I have another question. I don't think you can
That's fine.
Computations 2. Actually, the computations 1. I only watched the first class. Is it that you did several classes, probably up to class 4 for computations 1?
Yeah, probably. BODMAS and fractions, I see here I did in the first class.
Okay.
The second class, BODMAS with mixed fractions. The third class, fractions, decimal. So what would happen is computations 1 would probably be in class 2 or class 3. You know, and then computations 2 would probably be in either class 3 or class 4 as we go along. You understand?
Yeah. So, well, I want to look at class 1, so don't touch it.
No, that's fine, that's fine. But if it is that you look into class 2, you will see the corrections for computations 1. You should see the corrections there, right?
Okay.
Right. So all of the assignments, the corrections for those assignments are in the classes, so you can see everything being corrected, right? So it's just a matter of you actually have taken the time to look through all of the classes and things. So the next time, like when you're looking at class 2, you might see us doing computations 1, so you could sit down with your book and you could correct as you go along. Yeah?
Yeah.
Alright. Any other questions? Everything cracking. Alright. Okay, nice. This completes our introduction to algebra. So we're actually finished with the introduction to algebra there. Next class, which is Saturday, are actually going to be giving Alia a test. Now at the end of the day, Ariel and Shazay understand if you all do badly in the test, because you all haven't caught up yet. Okay? But Scotia and Caitlin, I think we agreed, you all know, like we finished number theory, so we had the exam 1. Well, we now finish the introduction to algebra, so we're gonna have exam 2, right? And exam 2 will be covering everything that we did in algebra, right? So, and we did a lot. Let me see what we do in algebra here, boy. Introduction to algebra. We start off with just the introduction. Just intro to algebra. We do some Mario Maths and thing. Corrections, right? So we had some corrections in terms of that. Subject to the formula, worded questions, substitutions, subject to the formula. Then we tackle laws of indices for like 3 classes. Laws of indices and square roots and all of these kind of things. So yeah, so definitely you guys have some catching up to do. You can see that in algebra we do have a lot more assignments with tons of questions. I would only advise Shazay and Ariel to just try to do 1 assignment a week. You don't want to overload yourself, because we have from now until exam next June real work we're gonna have to be doing. To tell you the truth, Ariel and Shazay, in order to catch up to all of these assignments, if you do 1 assignment a week, you might be able to catch up by December. Yeah? But still, Ariel and Shazay, it's cool if you catch up, as long as you go through it, because these are the most important classes, those first 12 classes, right? Another thing I have to tell you, right. You guys could feel free to come to the exam, so please come to the exam on Saturday. Even if you do badly, there's no problem, because remember, we'll be correcting it. So when we correct the exam, you will get to see everything and how everything has been done, right? So I might do the exam as a spotlight challenge. Who knows? We'll see how it goes, right? But that's it, guys. Take it easy.